Welcome to Lab 0, Introduction to R Studio. So if you have not done so yet, please go back into Canvas and open up Lab 0 as an HTML document so you can read along with me as I'm working through this, okay? So we need to start up R Studio. Go ahead and get that fired up if you have not yet done that. And you should be greeted with an environment that looks not quite unlike but similar to this. So we should have an empty console. You shouldn't have anything over in your environment, or you should see just your basic files over here, okay? All right, so this particular lab is all done in the console. It's just to show you kind of the conversational style that you can have with R. Basically, you're going to have a little chat with R. You're going to ask it to do some things. So just a few more things real quick about the windows here before we get started, or the different panes in the window. This is the console right here. This is where you actually input commands and ask R to do things. We can actually also ask R to do things through an R script or through an R markdown file, and we'll show that in the next lab. Over here is the environment. In the environment, we'll get to see any sort of data sets or anything that we've brought in or imported. Those will show up over here. These are the items or the objects that we can work on. It's a listing of those. There's also a tab for the history of the commands that you've done. You can see all the history of things I've been doing lately sitting in there. Down here, we've got the Files tab, which we've looked at before. It tells us all about where we're saving stuff. There's a Plots tab that we'll see where we get to plot things. We've looked at packages because we've installed some packages. There's a very nice help menu in R. We'll talk a little bit about that. And then there's a viewer. We'll come back to that later, okay? All right, so let's go ahead and get going on a little activity here. We're going to go ahead and enter in some data. So if you look in the lab, it says, to get started, enter the following R command prompt right after the greater than sign on the console, or you can type it in manually or cut and paste it. I think the cut and paste is, or copy and paste is the best way of doing that. So if you just highlight that and then right click on it and copy it, and then bring it back over to here into your document and paste it, you should get this source command. Now what this is going to do is it's going to go in and actually create a import a list of data for us, which is better known as a data frame. And so notice over here on the right hand side we see this data frame, which you can think about from your reading as a data matrix, and it tells us there are 82 observations on 3 variables. So it's from the Arbuthnot's baptism records. I'll let you do the reading on that about who he was. He was an 18th century physician. And just in here, I'm assuming you can read this. I'm not going to read it to you. I'm just going to go through the commands with you, okay? So let's go ahead and type in just the data name here. I'm going to type in AR. Now here's a very cool trick. Hit the tab key. And if you hit the tab key, you invoke what's called autocomplete, and it gives you options of things that begin with AR, and Arbuthnot is the first thing in there. So if you hit an enter, it'll finish typing that in for us. So if you hit an enter, notice we got all 82 observations. And what we have is in our columns is the years, number of boys, and number of girls. So each row represents a year, and the birth records represent the number of boys and number of girls that were actually born. So each row is, the beginning of each row is a row number. Those are not actually part of the data set. They mentioned that also in the lab, okay? A good way of thinking about it, as they said, is kind of like as you're working with a spreadsheet, it's telling you what row you're in a spreadsheet. Okay, so we can actually look at the dimensions of this by typing in dim, and we're going to get back is exactly what they give us up here in our data window. If you type in dim parentheses and again put in RA and then hit, whoops, did not want a capital. No, this actually was a good mistake to point out to you. R is case sensitive. If I put a capital A in there, it's not going to find what I'm looking for. So that was actually a rather fortuitous experiment or mistake to show you. Be sure and use the right case. It looks at a capital A very different than it does a lowercase a. Okay, so we see again the same numbers that we have 82 observations with 3 columns. So that's what the dimensions command gives us. If we do the names command here, type in names, and then put in our, it tells us that what the names of the 3 variables are. They're years, boys, and girls. Okay. All right. So let's go ahead and take a look at some of the things that they'd like us to do here. So, excuse me. This is referred to, let me back up for just a minute here, scroll back up for you. This is referred to as a data frame. We've talked about this in the textbook as a data matrix, but the same basic idea is that what we have is the rows represent the different observations and the columns represent our different variables. So within the data frame Arbuthnot, there are 3 variables. There's years, boys, and girls, okay? If I want to pull out just a single variable from Arbuthnot, then what I do is the following. I type in the name of the data frame first. Where do I want to go get my information? And then I put in a $sign as a delimiter, and then I put in the name of the particular variable I'm looking for. And if I hit tab, it'll do an autocomplete for me, okay? If I hit a return now, it's going to give back to me just the boys. In other words, it's going to be back all of the births for the boys, okay? All right, so what if we want to get the counts on the girls baptized? How would we do that? Well, to get the counts on the girls baptized, a simple way of doing that is hit an up arrow. If you hit an up arrow, it'll replay the last command that you just did, and then I can just type in girls here. So that's a very cool trick. Remember that up arrow trick. It's very handy when you're working on the console, okay? So now I have 2 variables here. I have the variable for number of boys baptized and number of girls baptized. And what I'd like to do is I'd like to take a look at a plot of the year by the number of girls that were actually baptized, okay? R's got some very, very amazingly rich features built into it, and one of them is its ability to do graphics, okay? So I'm going to come in here and adjust my window sizes just a bit here so that my plot window will look a little bit cleaner. So we're going to go in and use the plot command, and we need to tell it the 2 variables to plot. We need to tell it the x and the y. So we're going to say, well, x is going to be equal to, and we're going to say, well, I want that to be our buth, and then again here use the tab, put in the $sign, and then type in a y and hit the tab again. It'll do autocomplete for us. And then I'm going to let the y variables equal to, so you remember how to do xy plots, right? That's all we're doing here. Again, we're going to do the rbuth, and so then we'll do a tab, and then we'll put in our $sign, and then they ask us to do the girls here, so we'll do rbuth girls, okay? All right, so if you hit an enter, R executes that command, and if you look over in the right hand side now, you can see why I kind of changed my window sizes, because I want you to be able to see the plot. Now what it just did is it plotted the ordered pairs. So if you come in here and take a look at these each of these points represents an ordered pair of a year by the number of girls that were baptized. So if you'd like, you can actually get a bigger view of this by clicking on zoom, and it'll actually give you like a full size plot that you can take a look at. One of the beauties about our studio is that it's really easy to produce documents with these plots embedded into the document. Not something so easy to do in a standard word processor. Okay, well that was all well and good, but what if we want to actually see it instead of just the points? What if we want to have it as a line plot? Kind of think back in our algebra experience, we don't just plot points, we actually connect the points with line segments to see what it looks like. So R has the ability to do that also. So if I hit the up arrow, it'll replay the last command I did, and then come in here and put a comma again right after girls. Notice you always separate each of the individual commands by commas. Very important part that I kind of forgot to mention the last one there. If you got an error, go back and take a look and see whether or not you remembered to put the comma between there. Okay, so let's go ahead and put in the type here. And so this is a particular plot type. I'm going to put in the type equals, and now this has to be in quotes. When you put in a parameter like this, you almost always put quotes in it. And so we want it to be a line plot, so we'll put in an L. That looks a little bit like a ones, but don't get confused, that's an L there. Now if I hit a return, notice that we get a change in the plot, and then now instead of getting points, we've got lines, okay? All right, one last thing. to do here, a little extension over above what's on the lab already, is that we can also put in X labels and Y labels. Notice that it put in pretty much the names of the variables that were given to us in our data frame and in the data frame format. If we want to change that, we can add into our command an xlab for X label, and then put in an equals, and then open a quote, and then we can put in year, and then put in a comma here, and put in a ylab for a Y label, equals, and then that's girls, right? And you can put in girls baptized if you want to. Put my P in would be better there, huh? There we go, baptized. Okay, cool. All right, so I've executed this time. Notice that it gets the same plot, but we've got labels on our axes, which is a little more satisfying, I think. Okay, so the way you learn how to put in all these arguments is through the help menu. And one of the cool ways of getting help is from the console. You can put in a question mark, and then the command you're interested in, and it'll take you over into the help menu and automatically find that. And so this is generic XY plotting. And if you scroll through this, you'll see there are a huge number of different things that you can do to gussy up your plot, so to speak, okay? And there's actually some nice examples down on the bottom and more information on how to do it. So that's something to remember. Now you can also do it over here. You can click on help and you can type the command that you're looking for, and notice it gives you all the different varieties, like say we wanted to plot a density plot, and it'll show us all sorts of information on that. So you can get help that way also. You can use the tab in there, okay? All right, let's go back to our lab. So exercise 2, it says, is there an apparent trend in the number of girls baptized over the years? And it appears there is a very apparent trend. It appears that it was going up, but all of a sudden it crashes in this interval right here. So I invite you to Google what was going on in England during that period of time. I think most of us have heard about what happened during that period of time. It was a rather dismal time. It was when Newton got out of town, so to speak, when he left London. And so you can see that the overall trend is the number of girls who were baptized as time increases, but there's a interesting little anomaly right here, and I'll have you look that up and see what you think about that. Okay, so they ask us to do the same, but this time to plot boys and girls together. In other words, they want us to plot all of those together, all right? But first of all, a little bit of arithmetic. So let me just show you that actually R is an overgrown calculator. If I take 2 plus 3, back here, if I take 2 plus 3 and I hit an enter, R dutifully will tell us that that is 5. So R is very good. It knows how to do arithmetic, but even more importantly, it knows how to do column-wise arithmetic. It can actually take 2 vectors or 2 columns, not rows, 2 columns within our data frame and create a new column for us by adding those together. So for example, if we say we want Y to be equal to, well, actually I think I'll wait and not do that right away. I think I'll just put it to the home screen. Let's go Arbuthnot and let's put in the boys plus Arbuthnot, and then the girls, and we hit an enter, and what we get is the combined number of baptisms. These would be the children baptized. This is both the boys and the girls over the period of the study, okay? So what we want to do is we want to go ahead and plot that. So we're going to go plot, and we're going to let X be equal to, again, the years. And then we're going to have the Y be equal to, and then we're going to go Arbuthnot boys plus Arbuthnot girls. And so again, hopefully you're seeing the value of the tab when you're working in the console. It saves you just oodles of typing, and if you're like me and you're a really bad typer, that could just be, a godsend, okay? So there we go again. That's with with the plotting the points, I'd actually wanted to have that with the a line plot. So no problem, just hit the up arrow to repeat the command and put in type equals L. Okay, and we get the following plot, and we see that there was, pretty much consistency in the number of children being baptized combined with the boys and girls. Looks a lot like the girls plot. Okay, so as we move down in the lab, the next thing they want us to do is they want us to compute the proportion of boys that were actually baptized. Okay, so what we can do here is you can see that you could do division just as if you were doing addition, subtraction, all the rest of it as you look in the lab, right? And so we want to find the proportion of newborn boys that are labs, okay, labs, that are boys. So we want to find the proportion of newborns that were boys. Well, let's just do an example problem here real quick where they do. You take 5,218, and then they divide that by parentheses 5,218 plus 4,683. Okay, now the key thing why I wanted to stop and do this is to point out the use of parentheses. If I had forgot to put the parentheses in the denominator, I would have got back 4,684 because it would have only divided the 5,218 by the 5,218 and then taken that result and added it to the 4,683. In other words, R knows the order of operations. So since you're doing inline notation, you need to recognize that the division symbol here that you're used to using out there in the real world is a grouping symbol. But when you're doing it in inline notation or in a computer, you don't have that grouping symbol anymore, and you have to explicitly put that in there by putting in the parentheses. Okay, so there we get back the requisite percentage that we were looking for. Okay, so if we wanted to find out the totals or look at the percentages throughout, well, then we would just go Arbuthnot boys divided by, and now what are we going to do? Well, we need everybody. We need the totals of the boys and the girls, don't we, right? So we'll come in here and we will do the boys plus the girls again. Okay, and so what this returns is the percentage of boys that were born every year. Well, not necessarily born, excuse me, baptized. I shouldn't say that. I keep saying born, but it's because not every boy obviously was baptized. So these are all of the boys that were baptized in there, okay? So what if we wanted to make a plot of the proportion of boys over time? In other words, if we wanted to see what that looked like. Well, one thing that we can do is one of the things we can do here is to save ourselves a bit of having to type this all again, is go ahead and hit the y equals, excuse me, not just yet, I'm going to go ahead of myself, hit the up arrow, scroll over to the beginning of the command that we just put in, and type y equals. And what this is going to do is it's going to assign that to a new variable y. And if you take a look up here, notice we now have a new vector y, a new variable y, that has stored all of those numbers in there. And that's going to make our lives a little bit easier here. Why? Well, because I'm going to come in here now and do what they ask us to do. And they say, make a plot of the proportion of boys over time. And they want to find out, what do we see? Well, so I'm going to go in and put again, the x variable is going to be equal to the years. And now the y variable, I just have to type in a y. And I don't have to type in the whole command. Why? Well, because I've assigned the percentage of boys into the variable y. But of course, I do want to put in the line type again. That would just be Honda, because I don't want to see a bunch of points. I want to actually see it as a plot. And so would we see the percentage of boys being plotted with respect to time? I'll let you think about that. Does it seem to stay consistently above 50% on the baptisms or not over that period of time? Seems to be some fluctuation, but it seems to be hovering above 50%, doesn't it? Okay. All right. One last thing, and that is a new type of variable, and it's called logical variable. It's a really important variable in R. It allows us to compare things. And logic basically contains, in very simplest terms, it contains three conditions: greater than, less than, and equalities. So, for example, if we wanted to know the time where the values of the boys were greater than the values of girls, we could type in Arbuthnot boys. Where is that greater than Arbuthnot girls? And what that's going to do is it's going to return a logical variable, which is going to return a true or a false, okay? And so what we see for all of these data points, which, kind of goes back to our previous plot, they all came back true. In other words, it says for every one of the data points for boys that you looked at, though every one of those numbers is going to be greater than the data points for the girls. And of course, we scroll up and look in our console. That makes sense because notice these are percentages, and all of those percentages are above or slightly above 50%. So in all cases, the number of boys baptized was greater than the number of girls, wasn't it? So that's something to think about, okay? So real quick, the one way that R deals with these also is when you're working with these in terms of numerical values, it considers a true a 1 and a false a 0. Okay, more about that as we work our way through these incredible labs. Okay, all right, so on your own, you're going to get after taking care of some business here. There are 4 more questions that I'd like you to answer. You need to work those on your own. If you have any questions on those, please post them to the discussions area in questions for your instructor, and I'll get back to you as quickly as possible. So have some fun with R. Don't be afraid of it. If you get frustrated or confused by anything, please, like I said, don't be shy about posting questions to the discussion area. We can even set up a online office hour with a conference where I can help you one-on-one if need be.